Hey Sam, I have your unit review here to kind of go over real quick. You missed two questions, number 12 and number 15. So make sure I can get it all in one view here. Both Andrew and Carly recorded the distance they ran in X minutes on treadmills. I'm not going to look at the table just yet. Andrew and Carly each run for an hour. Which statement explains who ran a greater distance? So in order to figure this out, we need to calculate the slope. Basically, they've got two ordered pairs in both of these tables. Remember, the formula for slope is y2 minus y1 over x2 minus x1. x1 and y1 are just the first ordered pair in the table, and x2 and y2 are the second ordered pair in the table. Really, you can even flip those around just as long as you're consistent. So I will take, in Andrew's table, I will do 2 minus 1.5. And then 24 minus 18. Oh, my TV shut off. 2 minus 1.5 is 0.5. And 24 minus 18 is 6. And we can't have a decimal and a fraction. So let's go ahead and multiply. Let's see if we multiply the top by 2. 1/2 times 2. Multiply the bottom by 2. That's going to get 1/12. So that is 1/12 of a mile per minute. 1/12 of a mile per minute. Okay, let's check out Carly. 30 minutes for 3 miles, 40 minutes for 4 miles. So that's 4 minus 3 over 40 minus 30. This one's a little easier, 1 over 10. So that's 1/10 of a mile per minute. So let's read. So if Andrew's running a 1/12 of a mile in a minute, and Carly's running a 1/10 of a mile in a minute, let's see, Andrew ran a greater distance. The slope of the line described by the data in his table increased at a rate of 1/12 mile per minute compared to Carly's 1/10 mile per minute. So that's both correct. Let's see, what does it mean by a greater distance? 2 miles in 24 minutes. That's 1 mile in 12 minutes. And she runs 1 mile in 10 minutes. Okay, so I don't understand what it means by the greater distance. She ran 40 miles and he only ran 24. She's faster. So it looks like both of this part of the statement is accurate. The slope of the line described by the data in his table is at a rate of 1/12 of a mile per minute. Hers is 1/10 of a mile per minute. That's true. What this says is the exact same thing. It just has Carly listed first and Andrew listed second. It says Carly ran, because they run for an hour. Okay. So if she's running faster, sorry, I need to go back up here and read this. She's running faster. She's running a mile every 10 minutes. She's going to run 6 miles altogether. He's running a mile every 12 minutes. He's only going to run 5 miles altogether. And I'm just taking 60 minutes and I'm just dividing it by 12. Yeah, okay, so Carly runs the greater distance. She's faster. And if they both run for an hour and she's faster, she's going to run further. So that makes sense. Okay, let's go to question 15. Which equation represents a line that passes through the points 0, 6, and 2, 0? Man, I love this slope stuff. So these equations are in slope-intercept form. Y equals mx plus b. You can get there a couple of different ways. I do actually see the y-intercept here. Anytime you have an ordered pair that has a 0 for x, then this y is actually your b. But I can show you how to do it a different way as well. So first we want to calculate the slope. Let me erase that so it's just out of my way. So here we have x1, y1, and x2, y2. So that's going to be 0 minus 6 over 2 minus 0. So that's negative 6 over 2 or negative 3 over 1 or just negative 3. So the slope is negative 3. So that rules out the first and second options. You might have just had your slope flipped because you do have the right y-intercept, which is this number here. You're going to notice in the correct answer it's also a plus 6. So we have y equals negative 3x plus b. And if you're not sure what b is, you can take either one of those ordered pairs and plug them in for x and y. Or you can start with point slope form. I'm not sure that that's been taught to you yet, so I'm going to go ahead and show you plugging in either ordered pair. I'm going to go ahead and use this first one. I would put the 6 in for the y, and I would put the 0 in for the x, and I'm going to solve for b. So 6 equals negative 3 times 0 plus b. 6 equals, this cancels out, 6 equals b. So now I'm going to go ahead and rewrite my equation. Y equals negative 3x plus 6. This is definitely solving it algebraically. I'm not sure if maybe they also taught in the program, but if 0 is the x coordinate in an ordered pair that a line passes through, then whatever the y value is in that same ordered pair is your y-intercept. So that ordered pair is 0, 6. That means that's the y-intercept on the graph. Whoops, I'm going to undo that. On the graph, 1, 2, 3, 4, 5, 6, this graph would pass through the y-intercept right there. Okay, let me know if you have questions. It looks like you did really good on the rest of this. I'll go ahead and get this video sent off. If you want, I think I can add an attempt to the review. I'm not sure if you can just go in and redo those on your own, but I'll add an attempt in case you want to do it again. Or let me know if you need help with the test.